Thanks so much, Alessia, for the kind introduction. Also, thank you, Ramona, for those really exciting and inspiring remarks. I think we're going to touch on a lot of what Ramona mentioned also in this forthcoming panel, where we now want to focus the discourse, as Alessia already elaborated, on critical raw materials. And critical raw materials, just to summarize that once more, are such materials with high economic relevance because they are essential ingredients for products in strategic areas such as renewable energies, as Alessia mentioned, but also digital technologies, aerospace, or defense. And that can include, for instance, rare earth elements, which we'd find in permanent magnets, which we then use for wind turbine motors, for instance, lithium used in batteries, or silicon for semiconductors. And the European Union counts in the latest report 34 such critical or strategic materials, from lithium or cobalt or over materials with uncommon names such as gallium, but which we then need for high frequency electronics, or up to copper and nickel, which are not critical raw materials because they're not as scarce, but which are strategic materials because they're highly relevant for our economies. And many of that critical raw materials, and that adds some extra flavor to their criticality, have specific supply risks because there are no substitutes for them in the first place, and because most countries depend on imports and supply, that is extraction and processing, which we'd always both consider. And that supply is dominated by one or only few actors, or states even, and often enough authoritarian states. So circularity, which this day is all about, managing resources with great care, not letting them go to waste, preserving them over various product life cycles, once more not only becomes an ecological imperative, but an economic necessity and a matter of business continuity, basically, and a highly geopolitical issue, after all, that touches through all those effects that such materials can have, the very core, actually, of all our freedom and technological sovereignty. So worth some considerations, I'd say, and I'm very happy to have this panel here on stage with me. Three persons from very different backgrounds, as Alessia also mentioned, but all of them sort of have in common, I guess, that they're playing Champions League in their respective fields. Benedikt, as CEO of one of the world's leading mining and raw material companies, 80,000 employees, I believe, with operations in Kazakhstan, Central Africa, Brazil, and at the same time also co-chair of the Global Battery Alliance, which was founded at the World Economic Forum a couple of years ago. Very excited to hear about that. Sarah, Munich-based entrepreneur, but with a very interesting global background, co-founder of tozero, where we're going to be deep diving in later, the whole battery recycling value chain in specific. And then Michael, co-founder and general partner of Regeneration.VC, a highly, I guess, interesting fund investing in precisely those circular and regenerative solutions that we need. So thank you very much for being here, for making it all the way from Los Angeles, from Luxembourg or Amsterdam. Thanks for being here.
Thank you.
And Alessia already kindly mentioned myself. I can only repeat, with Circular Republic, we are trying to build that industry alliance that we need to foster the urgently needed collaboration across companies, and we try to pilot and scale the necessary closed loops within the different sectors. Currently working a lot in batteries, also in textiles, and soon also in electronics, and we're very thankful to be able to do that, thanks to BMW as our founding partner, and to many further partners joining that alliance, SAP, Tengelmann Group, and many others. Because I think we, and probably we agree on that, we're convinced that no one will manage circular economy alone, but we can only do it if we get all hands on deck and get that collaboration going, which is also going to be a part of our topic today, I guess. So now digging into critical raw materials and the relevance of circular economy in this regard, questions to Benedikt to open up. Two ones, actually. The first one's, where do you see raw material markets globally moving, specifically also with regard, of course, to critical raw materials? And second one, maybe a bit of a vicious one. Now, as a CEO of a mining company, how do you turn that, what I could consider sort of also nightmare from a miner's perspective, decoupling value creation from resource extraction, with this, which is the ultimate goal of circularity, actually to a dream, hopefully, that we share?
Thank you. Both very easy questions, I guess. Remember 10 years ago, if you were invited to a conference, you were always the representative of the people from the dark side of the moon. Right? The mining industry, the commodities industries, they were considered evil and part of the problem. My God, what has happened in the last 10 years is they were actually now considered part of the solution. You get invited to the State Department, to the European Commission, and to a conference like DLD. So a lot has changed over the last 10 years. It's an exciting place to be in raw materials today, because they've never been more relevant and more visible to the ordinary person. And I always like to make the initial question as people talk about raw materials and strategic critical raw materials, but very few people have actually seen them. That's why I usually take out some critical raw materials to show you. And I'm going to hand this to the front. You can give it around. I'm going to start with some graphite. That's in every one of your phones in the anode and the battery. I'm going to give you some tungsten. That goes into your wind farm to strengthen the structure of the turbines. I've got some copper. Most of you have seen copper. I'll just send this over here. And I've got what else here? This is the mix that goes into EV batteries. So it's got some no lithium. Don't worry, it's not going to explode. It's got some nickel, some cobalt, some manganese. There's some yttrium here, some rare earths as well. Somebody wants to see some rare earths. Now, the beauty of this is it has to come back here, right? That's called circularity. Because last time I lost the platinum block, so I get all of them back.
How much is that worth, such a block?
A block of platinum, it's probably going to be about $5,000 a day.
Oh, hello.
So it's not in there. Don't start looking. Anyways, but yeah, the raw materials industry has never been more important because the green energy transition is the biggest purchase order in the history of this industry, ever. And that's a great opportunity because the green energy transition requires a lot more materials for the same amount of output of, for example, energy. To give you an idea, a wind farm per unit of energy produced needs about 10 times more raw materials than, let's say, a classic gas turbine produced unit of electricity. 10 times. 5 tons of copper to make one windmill. One. 5 tons of copper, that's a block about the size of the two of us here, right? So you have to imagine that. And in order to mine 1 ton of copper, you need to move about 1 million ton of material around the world. And the same for batteries. A unit of, let's say, cobalt that's produced in, let's say, the Democratic Republic of Congo or Indonesia would go from Congo to South Africa, from South Africa to China, from China to Indonesia or Korea, from Korea to Japan, from Japan to the United States to make a car that is then shipped to Europe. Right? Just to give an idea of the amount of energy that's required, not just for producing it, but also getting it into an electric vehicle. And we estimate that over the next 15 years, probably 60% of the world's copper, 70% of the world's cobalt, 80% of the world's nickel, and 92% of the world's lithium that is produced will have to go into the green energy transition. I mean, these are amounts that this has never been done before in the history of mankind. And there are other uses for these materials today, right? And you can't just stop using the material for this and just shift it to the energy transition. So it's a real challenge. And on top of that, when you push a supply chain very hard to make it grow very, very fast, you do get a lot of bad behavior, right? People bend the rules because it's a very profitable business to be in. I mean, the average raw materials company last year made something like 60% net profit margin, 60, right? Not because we're against that, but it just happens to be an expression of supply and demand. And that's going to get worse, so it actually gets people into this industry that don't behave according to the global rules, and that's a real problem. So at the core of the global battery lines that we started about 7 years ago now, was to find a way to build a sustainable supply chain. Because when we are trying to do the right thing by supporting the green energy transition and a lower carbon economy, we don't want at the other side things to go bad. We don't want people to violate human rights. We don't want people to damage the environment. And that trade-off, I think, is today is a real dilemma because we haven't really figured out a way to do both, be green and to be clean. I think that's going to be a real challenge going forward. But it now gets the right attention. I mean, the idea of the European Commission to have 10% of its raw materials required for this transition to be produced in Europe, 15% to be recycled, and I think 40% to be refined. It's an expression also of the geopolitical importance that did not exist 10 years ago. I mean, the stuff came out of China and it was cheap, so what would be wrong with that? And I think today there's a real understanding that things might have to be a little bit more balanced because the green energy transition is a global challenge, and we have to make sure that we have sustainable and very robust supply chains around the world. So what taught at us during COVID and also during the crisis in the Ukraine, suddenly products that were available before were not available anymore. We had chips stuck in ports in China for 6 weeks during the COVID pandemic, so we couldn't move the product. Now we have to prove the product we sell doesn't come from a country A, B, C, D, E. We've never been asked that question before. So suddenly this becomes really at the forefront of a much bigger discussion, not just energy transition, but also geopolitics. And that's going to be a very big challenge as we try to expand the supply chain at a rate that has never been done in the history of mankind. Thanks.
And that affects both large industrial assets, and it also affects consumer goods after all. And we've seen that with the supply shortages in various contexts. Michael, thinking of Regeneration.VC, where you also invest specifically with a consumer-focused angle, maybe stepping one step back, you can give us a short overview of your activities at Regeneration.VC, but because I don't know if everyone's familiar, I think it's a very exciting group that you assembled there. It's all of you experts from entrepreneurship and venture capital, but you also have a former 4-star US Army general, you have Leonardo DiCaprio on your board of advisors. You have William McDonough even. So an extremely exciting group. How did that evolve? First question, and second question, where do you see the dynamics in terms of VC and entrepreneurship moving forward in terms of circularity?
Absolutely, and that was a really amazing summation of the current situation, Benedikt. And we're feeling that in our investments right now, as I'm sure all of us are in this room in different ways. But Regeneration's an early stage venture capital fund focused on what we call consumer climate technology. So when we set up the fund, consumer was a bit of a dirty word in the finance community. And when we looked at it, it's 60-70% of global emissions coming from the food we eat, the clothes we wear, packaging, the electronics, all of the products that are made from these base materials. And 93%, which we just heard from Martijn from Circle, is going to landfill, ocean, natural system. So we wanted to attack that problem and shift back, get somewhere closer to a zero waste world and beyond into a regenerative one. Could we reimagine consumer industries from this extension beyond planetary boundaries to ones that had the opportunity of creating a regenerative biosphere and positive outcomes? So that's really what we set out to achieve. There hasn't been a lot of funds like this, to your question on where the VC space is. Just in general around circularity, there's, call it a low 100 in the world of focused funds, and that's across all industries. Particularly ticking off consumer, there's even far fewer. So we raised our first fund, we've been deploying capital, and what's been really amazing is to see that the entrepreneurship is increasing, it's getting better, it's more global. Regulation is certainly driving quite a bit on that front. To give you an idea of what we specifically invest in, one, it's material inputs. We call this design. Most of environmental impacts are made at the point of design, which is something to think about. If we're more challenged on getting certain metal sets or critical raw materials, might we think around that to other ones or ways to even go beyond? For instance, we just announced yesterday an investment in ambient photonics, which takes light in a room and powers a device into a capacitor. So you don't need batteries anymore. You don't need little single batteries, circle batteries, AA, AAA. We did that with Amazon Climate Pledge and Ecosystem Integrity Fund. So Samsung remotes will come with no battery anymore. So that's a really exciting example where we can get rid of millions to hundreds of millions of these single-use batteries. Brands and services, these are the next great companies that bring material science to life and create circularity, and then reuse technology. Rent, repair, refill, your tactics that we'll probably be talking about quite a bit more today and referenced, and then reverse logistics. How do we get things back? And we need to measure and consider, should these things be brought back, and what are the implications of that? And in a world where raw materials are being more challenged and there are ever-growing amounts of things like e-waste, 80 billion a year of electronics getting thrown out, these are very rich pools to pull from in terms of urban mining and so on and so forth. So areas we're excited about.
Exciting, yeah. One material class that touches both consumers and industry at the same time is battery materials, I guess. And there, Sarah, I'm sure you can add some extra insights. Maybe you can give us a bit of an overview where currently, especially with regard to automotive batteries, where we need it urgently for electrification, where battery circularity is right now, and how you are also with tozero challenging that status quo.
I love that question. First of all, I'm super excited to be here with so many great people, actually experts within this industry. I'm Sarah, co-founder and CEO of tozero, and we recycle lithium-ion batteries, bring that circularity in. But before that, let's talk about critical materials. What is that? What is the definition of critical material? It is a material that doesn't mean it's rare. It's two different words. But critical is a material that is necessity, or there's a necessity or essential to keep evolving or keep innovating within the industry, and where a country is completely dependent for creating new innovations, such as the electrification of everything to build batteries, for instance. We're completely geopolitically dependent here in this regard. Where do the materials come from? I mean, I think it's super beautiful that we have the elements going around this room at this point. Let's start with lithium. Lithium, the white powder, the white gold, as we call it now in the critical material industry, comes from Chile, from Australia, from China. It is digged from the ground up, or from brines or from ores. Maybe roughly, maybe correct me if I'm wrong, you're the mining expert here. I'm just a recycling expert, but the density of basically the lithium within your ore brine is just reducing, it's diluting every single year. So maybe 0.2% of 1 ton of your ore is your lithium that you have to dig out and extract. So it's a lot of energy consumption that goes in here, a lot of chemicals that come in here as well to extract exactly those materials. That is then shipped to China, because the Chinese are always smart, conquering certain industries within time and owning certain capabilities within this world. So even if you dig it out in other countries, you ship it to China to create it into battery grade, so you purify it, you remove all the extra materials that is inside so that you can actually put it inside a battery. So that's lithium. Then we have nickel, you already mentioned it, mostly from Russia. We saw a huge spike during the Russia war, of course, the sanctions, where the prices jumped 200, 500 times within just a short time frame. I mean, great for the miners, bad for the battery industry who purchase these materials or are dependent on the supply chain that they can no longer depend on. Then you have it, of course, from Indonesia, from the rainforests. So there's some ESG difficulties here as well. Cobalt, Congo, you mentioned it as well. Yeah, I would say, the Chinese are smart here again. Most of the mines are owned by the Chinese, even across the world, and then they send it back to China to process it, to create it into battery grade. Graphite, over 80% of graphite is produced in China. I never mentioned Europe, so Europe doesn't have any of these critical materials. So our entire effort to get to carbon neutrality is dependent on these critical materials that we do not have here in Europe. We're completely dependent on the Chinese industry that they've built up within the last 10, 20 years, basically starting from the mining industry, working themselves up in the upstream, creating, let's say, refineries and purification efforts. And they more or less, if you want to produce a battery, you are almost to 90% dependent on the Chinese at this point.
And how do we still, at some point, they're imported to Europe, for instance. how do we then make sure to keep
Yes.
them in the loop or to
The
preserve
great
them?
thing is, so that's like where tozero comes in. The batteries are produced there. I mean, now more gigafactories are coming here in Europe by Chinese companies, by the way, so not European companies. The batteries are here, and we have these critical materials inside of the batteries. And this is a really awesome opportunity for us to extract those raw materials or critical materials outside of those batteries and reuse them. So that's what we do at tozero. So we recycle lithium-ion batteries. We exactly get lithium, nickel, cobalt, manganese, and also graphite outside of those materials, out of the batteries, and we sell them back to the industry. We sell them to the OEMs that are completely dependent on the materials, and also to the battery manufacturers. Yeah.
And quickly diving on the process level, correct me if I'm wrong, but what you basically do, you get black mass, which is the result of the shredding process, and extract by hydrometallurgy the relevant raw materials, so with chemical solvents, basically.
Yeah, like for the public, very many fancy words. For those who don't know, so if you shred a battery, you have, remember the plus and minus in a battery, there's a cathode and anode material. That's in shredded form. That's what we get from our supplier network across whole Europe. Currently, we can cover France, Germany, Switzerland, East Europe, and also Scandinavia at this point. And we get that shredded material, which is called the black mass. It's black because of the graphite of the anode material. And we run it through a chemical process, which is called hydrometallurgy. And we can extract, actually without using chemicals, it's more of a water-based solution, where we can, in a very environmentally friendly way, do urban mining. So we mine the batteries here locally in Munich.
Exciting. So that was a very deep dive into battery recycling. At the same time, maybe still touching on batteries, Benedikt, we can go on a more the macro perspective again with regard to global cooperation, co-opetition, I guess probably is again the right word here too. How does the Global Battery Alliance with the World Economic Forum relate to that, and what do you, also in your role, want to contribute there?
The Global Battery Alliance, or GBA as we call it, is I find a very exciting organization. Probably the largest organization in the space with about 150 members now. Companies like Tesla, like Volkswagen, the World Bank, UNICEF, the German government, the Canadian government, the Japanese government. So it's a multi-stakeholder initiative that was originally founded at the World Economic Forum. And we have the intention, as I mentioned earlier, to build a traceable, transparent, sustainable value chain of one of the fastest expanding supply chains in the world, which is the energy storage supply chain. And as we all know, no energy transition without energy storage, even though maybe your investment might change that very quickly now. So, but really the objective is to create transparency in the supply chain. And why transparency? Because it makes a huge amount of difference whether 1 unit of nickel, and you mentioned nickel as an example, is refined in a Canadian hydroelectric power-based refinery, or whether it's produced out of limonite ore in the Indonesian rainforest with tailings and waste going into the Pacific Ocean. It makes a huge difference, right? The CO2 emission footprint is going to be incredibly different, and the same for cobalt and other units as well. So you have to create transparency. And the ESG score of these two different products is going to be fundamentally different depending on the way of production, the location of production, and so on. So we actually published the first, we call it the battery passport in Davos in January this year, which is the first passport that actually creates transparency around the provenance, the ESG score, the human rights score, the CO2 footprint of these individual elements that go into the car battery. We had a pilot, both Audi and Tesla had pilots in their cars. Audi were using them, they have the cars and the forum in Davos. So they had this sticker on the back, and you could scan the sticker, and it will tell you where does this unit of cobalt originally come from? Where has it been refined? Where has it been processed? And where has it been sold? We're also very happy because we don't, everyone likes to talk about China, but you have to actually talk with China, because China is 80% of the world's battery supply chain, 90% of the world's battery supply chain. So it's not enough to talk about China, you have to talk with China. That's why we have EV100, which is the government organization in the Global Battery Alliance. And my co-chair is Robin Zheng, the owner and founder of CATL. I always like to call Robin, you're like Standard Oil of the energy transition, right? Because you've got mines, You've got processing plants, you make cells, you make batteries, and you produce the batteries in Europe, around the world. So that's the closest you can get to a fully integrated energy transition business. And no surprise, he's got a $50 billion valuation. And they came out of nowhere 10 years ago. I couldn't tell you, no one in this room would have known CATL, no one. And now it's the biggest company in the energy transition. So the objective really is to have a digital twin of every single battery. We start with electric vehicles. We're now going into the electronic space as well, because that will make the circularity so much easier. Of course, the lowest CO2 emission unit of nickel or cobalt or lithium, the lowest and the best score from an ESG point of view will be the recycled unit. The challenge with this is, it's not the technical problem to recycle materials out of the supply chain. It is an economical challenge, and it's a question of scale, because there's just not enough material in the supply chain today that can be recycled to make a material difference. I mean, if we're talking 5%, 10%, 50% of future demand coming from recycling, that would be a great success. Today still, to give you an idea, in 2027, the electric vehicle industry will consume the entirety of the cobalt production and the lithium production of last year. Right?
What you've elaborated, I'm just jumping in because I'm looking at the time, is basically two things I hear from that. The power that challengers can have on global markets, and also the role of digital transformation that sort of, goes all the way through whatever industry we have there. Maybe one question as a wrap-up to you, Michael, with the, please answer in very briefly. Where would you say, which will be the role of innovation in general and entrepreneurship and VC in specific on our way to circularity, and when will we achieve that?
In as little time as possible.
Short answer.
Yeah, I'll dodge it just a bit. I mean, we obviously see the potential in a ton of innovation happening in the US, here in Europe, and many pockets globally. The product passport thing is a big deal. So the EU Circular Economy Action Plan has product passporting for apparel and for electronics and for packaging and other goods. And what this is going to mean and start to unlock is the provenance of where things are coming from, how they're being made, where they travel, and it's going to change the fundamental value, we believe, of some of these product sets. It's also a force function to create more transparency, particularly around Scope 3 emissions. Some of the challenges of having these open passports is this is not information suppliers want to share at all. This is highly competitive information. So the way in which we can do that and create a safe framework for that to happen is vital, and we'll see a lot of innovation there. But yeah, very, very exciting stuff.
Exciting. And I think that also fits perfectly as a wrap-up, because up now is apparel and fashion industry coming, and I guess I can be handing over to Steffi or whomever is taking over. Thank you three so much, and thank you to everyone in the room.